Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a theory paper. We call it paper 2. And for this purpose, we have selected October-November 2010 2-2 paper. This paper 2 belongs from the zone 2. Today in this video, we are going to solve the section A of this paper. The total time allowed for this paper is 1 hour 45 minutes. And there are 75 marks for this paper. And in this video, we are going to solve the section A. In the section B of this paper, I will solve in another video. So let's start today's paper. So on your screen, October-November 2010, paper 2 from the zone 2 is showing up. The time allowed is 1 hour 45 minutes. And let's start. So the first question, section A. Figure 1.1 shows a cricket ball as it comes into contact with a cricket bat. So you can see a cricket ball which is coming in this way, then it comes in contact with the cricket ball, and the batsman will hit the ball. And one thing is very important. You see, when the ball is coming into towards the batsman, towards the bat, you call this direction, suppose you call it positive direction. And when the ball will go, and when he will hit the ball and the ball will go in other direction, the opposite direction, we will call that direction negative. If you suppose that the ball coming towards the bat, that is negative direction, then the ball going away from the bat, when the bat will hit the ball, that will be then positive. It's up to you. The cricket ball has a mass of 0.16 kg and it hits the bat with a speed of 25 meters per second. After being in contact with the bat for 0.0013 seconds, the ball rebounds with a speed of 22 meters per second in the direction exactly opposite to its original direction. State the difference between speed and velocity. You know, the speed and the velocity is a 1-mark question. Speed is distance divided by time, whereas the velocity is displacement divided by time. Another difference between them is the speed is a scalar quantity, whereas the velocity is a vector quantity. So my answer is speed is distance covered per unit time, velocity is displacement covered per unit time. So here we have the marking scheme. So marking scheme is showing up on your screen and you can pause the video here. Okay. Then we have, he says, calculate the change in the velocity of the cricket ball. The initial velocity of the ball is 25 meters per second. The final velocity of the cricket ball is 22 meters per second, but both the velocities are in opposite direction. So if you will suppose that 25 meters per second, which is the ball is coming towards the bat, if that's positive, then the 22 meters per second, when the ball is going away from the bat, that will be negative. Or you can do it the other way around, and you can suppose that the 25 is negative and 22 is positive. So we have to tell them what is the change in the velocity. The change in the velocity will be V2 minus V1, final velocity minus initial. I have supposed that the final velocity is positive and the ball coming towards the bat, that's negative. So 22 minus 25. So it will become 22 plus 25. And so the change in the velocity will be 47 meters per second. 47 meters per second is the right answer, sir. Okay, so question number 1B, second part, the average acceleration of the ball while it's in contact with the bat. You see, the acceleration is change in velocity divided by time. So the duration of the contact with the bat of the ball was 0.0013 seconds. So the acceleration is change in velocity divided by time. So it will be v2 minus v1 divided by time. So it will be the change in the velocity was 47 and the time was 0.0013. So the acceleration will be 47 divided by 0.0013. So when you do this on your calculator, you will get 3.6 expo 4 meter per second square. 3.6 expo 4 meter per second square. So our answer is right. So this is the solution. Question number 1B, third part, the average force exerted on the ball by the bat. You know the resultant force that is equals to, according to Newton's second law of motion, F is equals to ma. So we will apply that. We know the mass of the ball, and the mass of the ball is given, that is 0.16 kg. So F is equals to ma. So mass is 0.16 kg, and the acceleration is 3.6 x per 4 meter per second square. Just put these values and you multiply them on your calculator, you will get 5.8 x per 3 Newton. 5.8 x per 3 Newton. So you can see our answer is right. So this is question number 1. Hopefully you know how this is done. Okay, so we are on the next question, and the next question is question number 2. A U-shaped tube of constant cross-sectional area contains some water of density 1000 kg per meter cube. Oil that does not mix with water is then poured into the right-hand side of the tube. Figure 2.1 shows the level of the water and the oil when equilibrium is reached. Okay, so it's a U-shaped tube. So here, this blue thing, that is oil, and this is water. Okay, and they do not mix with each other. So this is point X and this is point Y. The point X and Y are at the same horizontal level. X is 0.066 meter below the top surface of the water. Y is 0.075 meter below top surface of the oil. State two quantities that influence the pressure beneath the surface of a liquid. You know the pressure of a liquid is rho GH. Rho GH, where the rho is the density of the liquid, G is the gravitational field strength at that point, and H is the depth of the liquid above that point. So these are the factors which influence. And let me show you my written answer. I have written density of liquid and depth of the liquid above the point of observation. So question number 2, the marking scheme, you can see A part, the marking scheme is showing up. Okay, so this is my answer. Question number 2, B part. In the question number 2, B part, he says the cross-sectional area of the tube is 5 expo minus 4 meters square. First part is calculate the mass of the water above the level of the X. So we have to calculate what is the mass of the water. We know the depth of the water here above this point, that is 0.066 meter. And we know the cross-sectional area, so I can find the volume of the water. And then here you can see the density of the water is also given. And if you know the volume of the water and you know the density of the water, you can find out the mass of the water. You know the density is equals to mass divided by volume. So the mass is equals to density multiply volume. So let me show you my solution. Okay, so here we have. So volume will be equals to the area, cross-sectional area multiply the depth. The cross-sectional area is 5 expo minus 4 meters square. The depth is 0.066 meter. So just multiply them, you get 3.3 expo minus 5 meter cube. That's the volume of the water. The density is mass divided by volume. So the mass will be density multiply volume. So we know the density of the water, that is 1000 kg per meter cube. So 1000 multiply 3.3 expo minus 5. You get 3.3 expo minus 2. And that will be 0.033 kg. So that is the mass of the water. Mass of the water will be 0.033 kg. So our answer is right. This is the solution. Okay, so question number 2b part, second portion. The pressure caused by 0.066 meter of water at X is equals to that caused by 0.075 meter of the oil at the Y. Determine the density of the oil. You see the pressure at the point X and the pressure at point Y, they both are equal to each other. But the pressure at the point X is due to the water of depth 0.066 meter, and the pressure at the point Y is due to the pressure of the oil of the depth of that oil is 0.075 meter, and both the pressures, they are equal to each other. So the pressure of a liquid is rho gh. So rho 1 gh1 equals to rho 2 gh2, because they said that the pressures are same. Okay, so rho 1 is the density of the water, that is 1000, and g is 10. H1 is 0.066. H2 we don't know, we want to find out the density of the oil. The g value is also 10, and the H2 is the depth of the oil above the point Y, that is 0.075 meter. So if you will make rho 2 the subject of the formula, so you will have 1000 multiply 0.066 divided by 0.075, and the answer will be 880 kg per meter cube. That will be the density of the oil. I hope you understand the strategy how we have done this. So 880 kg per meter cube is the right answer, sir. This is the solution, and I hope you understand. So we are done with the question number 2. Now we are going to the question number 3. Figure 3.1 shows a firefighter. Here we are showing a firefighter of total weight 840 Newton in equilibrium at the top of a ladder that is pivoted at the point P. So basically we are talking about a firefighter, which is here. Here we have the firefighter. It is on a ladder, and the ladder is pivoted here. So around this the ladder can move. Okay, so the firefighter's weight is 840 Newton, sorry. And you can see the question is, the ladder leans towards a burning building at an angle such that the center of the gravity C of the firefighter is 12 meter above and 5 meter to the right of the P. The firefighter holds a hose that directs a high-speed jet of water horizontally into a burning building. Calculate. First part is calculate the moment m of the firefighter's weight about the P. Okay, so you see the firefighter's weight is acting in this line, and the perpendicular distance between the line of action of the weight of the firefighter and the pivot is this much. It is 5 meters. So the weight is acting along this line, and the perpendicular distance between the line of action of the weight and this pivot is 5 meters. So the moment arm is 5 meters, and the weight of the fighter is 840 Newton. So I can calculate the moment produced by this, the weight of the firefighter. The moment is weight multiply the moment arm. So here we have the moment will be equals to force multiply the moment arm. The force is the weight, and that is 840 Newton, and the moment arm is 5 meter. So 840 multiply 5, that will be 4200 Newton meter. 4200 Newton meter is the right answer, sir. Question number 3, it's second part. Second part. The jet of water causes a horizontal force R on the firefighter that acts towards the left through C. This opposes the turning effect of his weight. Calculate the size of R that on its own ensure that M is exactly cancelled. Okay. So due to the jet at point C, a force is exerted on this firefighter towards left. So it's trying to produce an anti-clockwise moment, and that will cancel the clockwise moment produced by the weight of this firefighter. Because here the reaction force will be acting in this direction. So the line of action, as you see, the force will be acting in this direction. So the perpendicular distance between the line of action of this force R and the pivot will be 12 meter. So the moment arm for that force will be 12 meter. And the moment produced by this force R will be equal to the moment produced by the weight of the firefighter. So you see, moment produced by the weight of the firefighter we have already calculated, that is 4200 Newton meter. So the moment produced by that force R, which is due to the jet of water on the firefighter, that will be R multiplied 12. R is that force and 12 is the moment arm, and that is the perpendicular distance between the line of action of that force and the pivot, that is 12 meter. So R multiplied 12, that is equals to 4200 Newton meter. 4200 is the moment produced by the weight of the firefighter. So R will be 4200 divided by 12, and that will be 350 Newton. So the force produced by the jet of water is 350 Newton, and our answer is right. Okay, so then we have another question, and it says, suggest a third force that has a turning effect about the P on the ladder. So yeah, the third force is the weight of the ladder itself. The weight of the ladder, also the weight of the ladder is acting, suppose this is the center of the gravity of the ladder. So here the weight of the ladder will be acting in the downward direction. So another force which is producing a moment, and that moment we hope is in the clockwise, that will be a clockwise moment, and that is the weight of the ladder. So let me show you. Weight of the ladder will produce clockwise moment about the P. That is my answer. So let's check. Weight of the ladder, okay. So is my answer, okay. So you can pause the video when I showed you the marking scheme. Okay, question number 3, it's B part. He says the figure 3.2 shows a firefighter. So it's a firefighter. He is wearing a mesh t-shirt, a shiny jacket. Okay, the question is the jacket uh, of his protection suit has a shiny silver colored outer surface. Underneath it, he wears a loosely woven mesh t-shirt, string vest we call it. Explain how wearing the shiny jacket and the mesh shirt helps to keep the firefighter cool when he is close to a source of intense heat. You see, the outer surface of his jacket is shiny and it is silver colored. You know, the shiny silver color is a very bad absorber, or it's a very poor absorber of the infrared radiation. So when he will be near a source of intense heat, due to this silver shiny color, the outer surface of his vest, the heat absorbed will reduce a lot. And the mesh t-shirt he's wearing, because the mesh t-shirt will have trapped air in it. When he will wear his shiny jacket over this mesh t-shirt, the air will be trapped in the mesh t-shirt. When the air is trapped, the air is a bad conductor of heat. So that trapped air and this mesh t-shirt will reduce the transfer of heat by the conduction from the surrounding to his body. So by these two things, he will be able to go near the source of intense heat, and the heat absorbed and reaching his body, that will be reduced. So he will be able to work near the source of so here we have this answer, and this answer is written by one of my students, and her name is Aisha. Thank you to her for writing the answers. The mesh t-shirt traps air. Air is a poor conductor, so it prevents convection and conduction taking place. Shiny jacket is a good reflector of heat, so no heat energy is absorbed and firefighter remains cool. Okay, so the marking scheme is a good question. Question number 3, B part. Any 4 lines, you can write the mesh traps air, air poor conductor, it's a good insulator or convection prevented. Shiny surface reflects, good reflector of the infrared radiation or heat. Shiny surface does not absorb, it's a poor absorber of the infrared radiation or heat, not with the radiator, emitter, or conductor. Less heat transmitted to the firefighter. So this is the answer. We have also written, Aisha has written a good answer as well, but you can write a better answer always. So we are done. Question number 4 is now showing up on your screen. He says, at night, a bright floodlight is used to illuminate a building. The floodlight is a metal filament lamp. It is connected in series with a variable resistor and a 230-volt mains power supply. When the floodlight is first switched on, the resistance of the variable resistor is at its maximum value. In the following few minutes, the variable resistor is adjusted so that its resistance decreases slowly to 0. This causes the brightness of the lamp to increase until it reaches a maximum. At maximum brightness, the current in the lamp is 12 ampere. Calculate the resistance of the lamp at maximum brightness. Okay, we know the voltage drop, and we know the current flowing, so we can calculate the the resistance of the lamp. And you know, when the brightness is full, the variable resistor which was connected in series with the lamp, its resistance we have made 0, so there is no voltage drop there. So all the voltage which the battery is providing, or the EMF of the battery, all that voltage will be dropped across the lamp. So because the resistance of the variable resistor, we have made it 0. So the voltage drop across the lamp will be equals to the EMF of the battery. That's 230-volt. I said battery, its main supply, and the current is 12 ampere. So we can calculate the resistance. You know, according to the Ohm's law, you know, the V is equals to IR, and R will be equals to V divided by I, voltage divided by current. So 230 volt divided by 12, that is 19.16. So it's approximately 19.1 ohm, 19.1 ohm. So here we have 19.1, 19.2. So that is, the unit is ohm. I hope you understand. Okay, so we are going to next question. State and explain what happens to the resistance of the lamp as its brightness increases. You see, as the lamp brightness increases, the temperature of the filament increases. So when the temperature of the filament increases, its resistance also increases. And the filament lamp is a non-ohmic conductor. Its resistance do not remains constant. It with the as the brightness increases, its temperature increases, so its resistance also increases because of the temperature increase. So here we have the answer, written answer. When the brightness of the lamp increases, its temperature increases. As a result, its resistance also increases. So marking scheme says resistance increases as the temperature increases, gets hotter, gets heated. Okay, so this is our answer. Okay, the C part of the question number 4. Suggest how by using the variable resistor in this way, the filament lamp is protected from the damage. You see, we have connected a variable resistor in series with the filament lamp. And before switching on the circuit, what we do, we make the resistance of the variable resistor maximum. And when we do that, you see the equivalent resistance of the circuit becomes high. And due to this, small current comes from the battery or from the main supply. And then we gradually reduce the resistance of the variable resistor. And then when we reduce the resistance of the variable resistor, the current from the battery gradually increases because the circuit's resistance decreases. And how this protects the lamp? For example, it's possible that if the resistance of the lamp is low and the large and excess amount of current will come from the main supply, and which will overheat the filament lamp, and its filament will break or the bulb will get fused. So by using the variable resistor, we have protected the filament lamp from getting overheated due to excess amount of current flowing through it. Using the variable resistor in this way prevents high current from passing through the circuit. So the bulb is not damaged, it does not glows. If we switch on suddenly, low resistance and high excess current will flow, or it prevents high excess current, bulb filament fuse blown damage, or wire damage, or filament lamp, ignore filament lamp damage. The wire will melt actually. See what happens. So we go to the next question. The next question is question number 5. A microphone is connected to a cathode ray oscilloscope. We call it CRO. A note produced by a musical instrument causes a trace on the screen. The trace is stored electronically in the CRO. Figure 5.1 shows the stored trace display on the screen. Okay, so here we have that display. So you can see here we have this wave, and to complete one wave is from here till here. Horizontally we have 1 2 3 4 divisions, and 1 2 3 4 1 2. So there are basically 2.5 waves showing on the screen of the CRO, and each wave horizontal, it taking 4 divisions on horizontally. You know, the CRO, on the x-axis we have time, on the y-axis we have voltage or amplitude. The time-based setting on the oscilloscope is 0.2 millisecond per division. This is important. Each square horizontally represents 0.20 milliseconds. Okay, so determine the frequency of this note. From here, from this graph, I can tell the time period. So the strategy is, first of all, from the graph, I will tell what is the time period. Once I know the time period, then I will apply the formula that frequency is the reciprocal of the time period. But one thing you have to keep in your mind, When you are using this formula, the time must be in seconds. It cannot be in milliseconds. Okay. So to complete one wave, there are 1, 2, 3, 4 horizontal square. So the time period for one wave will be 4 into 0.20 millisecond. So you will get 0.80, and that will be millisecond. And millisecond means 10 raised to power minus 10 raised to power minus 3 seconds. So then I will convert it into seconds, and then we will put these values and we will be able to tell. Okay, so the time for one complete wave will be 4 multiplied 0.2 into 10 raised to power minus 3, and that will be 0.8 expo minus 3 seconds. Frequency is 1 by t, reciprocal of the time period. So it will be 1 divided by 0.8 expo minus 3. Enter this in your calculator. You will get 1250, 1250 hertz. 1250 hertz. 1250 hertz is the right answer, sir. This is the solution. Okay, then he says a note from a second musical instrument is played and the trace S produced by the new note is also displayed on the screen. Figure 5.2 shows the screen displaying both the original trace and S, the second trace. In each of three spaces below, describe either a similarity or a difference between the sounds made by two notes. So we have to tell three things, either similarities or differences. Okay. So you can see this trace, the S is till here completes one wave, till here it completes one wave. So their time period, here the first wave is completed, here the second wave is completed. So the time period for both the waves is same. If the time period for the both waves is same, that means their frequency will be also same. You can see that the amplitude of the first wave is higher and the amplitude of the second wave is less. So I can write here two similarities. One similarity is they have the same time period. The other similarity is that they both have the same frequency, and the one difference between them will be that they have different amplitudes. Okay, the wave S has less amplitude. So let's check what we have written here. Okay, both have the same frequency. Original note is louder than S because it's the original note's amplitude is larger, so it is louder than S. Both notes have different qualities. Yeah, this is also a difference between them. The basic shape of their waves is different from each other. So we call it quality. So the quality is also different. So you can say equal, same pitch, same frequency, original note louder. Okay. And different qualities, and we also call timbers as timbers, and okay, so that is our answer. So you can have a look at this marking scheme. We have already checked our answer, so we are done with the question number 5. So now we are on the question number 6. Figure 6.1 shows a metal bar placed inside a vertical solenoid. So here we have a solenoid, which is a metal bar. Around it, we have wound a wire, and it has been connected with a DC power supply. And obviously, when the current will flow through it, and this solenoid will become an electromagnet. When it will become an electromagnet, it will attract these paper clips. And some of the paper clips will get attached here. When you will switch it off, it will be no more an electromagnet, and paper clips will fall back into that container. The solenoid is a coil of several turns of insulated wire. A DC power supply is connected to the solenoid so that there is a current in it, and when the supply is switched on, the metal bar is a short distance above a small pile of iron paper clips in a glass dish. The power supply is switched on, left on for several seconds, then switched off. Describe the behavior of the paper clips when this procedure is carried out using a metal bar of aluminum, iron, or steel. You see, the aluminum, when the metal bar is of aluminum, the aluminum will not become electromagnet. So the paper clips will be not attracted to it. If you have iron, the paper clips will, because the iron bar, then the paper clips will be attracted to it when the current will be flowing through that solenoid. And once you will switch off, what will happen? The iron is a soft magnetic material. So immediately that iron bar will lose all its magnetism, and all the paper clips will fall back into that container, glass container. If you use a steel metal bar, you see, when you will switch on the DC current, the steel metal bar will become magnetized and it will attract the paper clips. But when you will switch off the current, the steel is a hard magnetic material. And once it has been magnetized, it can retain its magnetism for a very long time. So you have switched off the current, but now the steel will not demagnetize immediately. It will retain its magnetic properties for a longer time. So a lot of the paper clips will still remain attached to that steel rod even after you have switched off the current. So I think this is my description. Okay, let's see what answers Aisha has written. No effect, as aluminum cannot be magnetized, so it does not attract the paper clips. Initially, paper clips are attracted to it, but when it is switched off, when the current is switched off, paper clips will fall down. Because the iron is a soft magnetic material, it makes temporary electromagnets. Steel, or you can say magnets, steel, paper clips are lifted up and remains attracted uh, even after switching off the current, because the steel is a hard magnetic material, and the steel, once magnetized, it retains its magnetic properties for a very long time. So let's check. So this is the marking scheme. Question number 6. A part remains stationary, no effect, unaffected, lifted up, attracted, stick to the rod, fall down, returns to the dish. C part is lifted up, attracted, stick to rod, stays up, remains attracted. Okay, so we are going to the next question. That is question number 7. He says, explain what is meant by background radiation. Background radiation is the radiation which is all the time present in our environment. So we are used to this radiation. We call that background radiation. The radiation that is always present in the atmosphere due to the natural sources is called the background radiation. So let's have a look at the marking scheme. So any two ionizing nuclear, alpha, beta, or gamma, always present, inescapable, the environment, air, atmosphere, surrounding cosmic radiation or radiation from the sun or space. Okay, question number 7, and its B part is, describe how one human activity has led to an increase in the background radiation. You see, the increase in the background radiation due to human activities, there are so many human activities which has increased the chances of this sorry, they have increased the background radiation. For example, the humans, they are doing the nuclear testing that causes sometime, there is some accident in the nuclear reactor due to which this radiation comes out. And sometimes, um, the waste of the nuclear reactor, which is still radioactive, that is not properly disposed. And that also causes the back increase in the background radiation. And these are the disposal of the nuclear waste from nuclear power station leads to an increase in the background radiation. Okay, we are doing the improper, not the proper disposal is being done. Named activity, nuclear test and nuclear power, that's the disposal of the nuclear waste, water leaks traced, and disposal of the radioisotopes and absorption of radiation, radioactive ore mining, isotopes exposed, smoke detectors. We put smoke detectors in our home, so they have that radioactive substance in them. Specific industries use, for example, nuclear medicine. So this is the marking scheme. You can read it. You can pause the video, take your time. Okay, so we are going to the next question, and the next question is question number 8. He says, explain in outline how a low density cloud of hydrogen in space becomes a star. Okay, so you see, in the start, we have that nebula, and nebula is gas and dust. And due to gravity, that gas and dust come close, close, close. And when it comes due to the gravity is causing an inward force, and those gases and dust, they come very close to each other. And they come so close to each other that the very simple element in it, which is hydrogen, its nucleus, they start to fuse into each other. Once this happens, the process of fusion starts, and a lot of heat is produced. And when this happens, this causes an outward force, and the temperature and increases. And when this happens, the energy which is produced from the nuclear fusion, that is in the outward direction. So that is trying to explode the star, and the gravity of the star, which is directed towards the center, that is trying to pull it inward. So then there creates a balance between this inward and outward force. And when this happens, the star is in its stable state. We call it the main sequence star, or we call it the stable star. So this is how how that cloud becomes stable star. So here we have the answer written by the hydrogen molecules in a low density cloud in space are pulled together due to the gravitational attraction. As the mass of the gas cloud increases due to the joining of more molecules, the intermolecular forces of attraction increases. So the gas cloud squeezes. As a result, the temperature of its inner core increases. When the temperature of the inner core reaches millions of degrees centigrade, the process of nuclear fusion of hydrogen starts occurring, which further increases the temperature of the inner core. At an extremely high temperature, the the high density cloud lit up to become a star, a young star of the size of our sun forms a yellow or red star, and a star about 20 times bigger than our sun forms a blue or white star. So this is the answer is a little longer. You can still squeeze this answer. You can reduce this answer. So listen carefully from what the marking scheme wanted us to write. 1 mark for gravitational collapse of hydrogen cloud or gravity pulls cloud together or lose of the gravitational potential energy. 1 mark for saying that temperature increases or gain of the kinetic energy. 1 mark is for saying that the fusion of hydrogen or hydrogen to helium and energy released or exothermic or equilibrium or pressure cancels collapse. And 1 mark is for saying or pressure increases, not density increases. Okay, so I hope you can write, because now this is this topic, especially the birth of a star, because a new chapter has been added into the syllabus, which will be starting from its assessment is starting from June 2023, May June 2023 exams, and in which we have that chapter, the space physics, and you can read that chapter also. And I hope you can write a better answer than the answer which we have written. It's a 4 mark question. So my dear students, we are done with this portion. And so, my dear students, today in this video, we have done October, November 2010, Physics 505422, Section A. There were 8 questions in the Section A, and we have done all of those 8 questions in this video. The Section B of this paper, I will do in another video, and soon I will upload that. You will be able to find that Section B also in the same playlist where you have found this paper. And so I have done my best to explain you the concepts. Mistakes can happen. If you think that there's mistake, I always believe that my students can write better and better answer. You can discuss the answers with your teacher, with your class fellows, with the you can consult them with the marking scheme also. So thank you very much everyone for watching this video, taking out time. If you think that this video can help you, it can help your friends, it can help your junior senior students or your teacher, please share the link of this video with your teacher, with your students, with your class fellows, with your junior students, with your senior students, by sharing the link of this video onto your Facebook, onto your Instagram, onto your Twitter account. When you do this, this helps me to promote my channel. I think it's a great blessing for me that I can make these videos which can touch the life of so many students around the globe. Thank you very much. Have a good day. God bless you all.